Welcome back to this channel. In this video, we are going to find the nth term of a sequence that is fractional and arithmetic in nature. Here's the first example. We have this sequence made up of fractions 1/3, 2/5, 3/7, 4/9, etc. So what we do here is we separate the numerators from the denominators, so we will kind of have two separate sequences, and we find their nth terms separately, and then we'll combine the nth terms as one fraction again. So let's do it. For the numerators, we have 1, 2, 3, 4, etc. And as we have learned, the two methods of finding the nth term, here's method 1, where the nth term is an plus b. A is the common difference and b is a number you find by substituting a term and its position. A term value is xn and its position is n. So in place of the value, in this case, I picked the first term, which has a value of 1 and its position is 1. Now the common difference, how you get from 1 to 2 and 2 to 3 and 3 to 4, is plus 1, positive 1. So that's the value of A. A is 1. We substitute this in and we find the value of B. Then we're going to plug B back in with A and we'll find our nth term rule. So that gives us 1 on the left hand side. 1 times 1 is 1. 1 plus B on the right side. And to find B, we minus 1 on both sides, giving 0 equals B. So the nth term for the numerators is going back to the format of an plus b. We leave our a. We substitute a, we substitute in b, but we leave n. And again, a is the common difference, 1. And b we found to be 0. So we go xn is 1n plus 0, which simplifies to n. So n is the rule for the nth term for the numerator. Now we do the same for the denominator. And our denominator included 3, 5, 7, and 9. So take note, I am using the other method. Tn is a plus n minus 1 times d. In this method, a is the first term and d is the common difference. We just substitute these two things in the first term in the sequence, and the common difference. So the nth term is 3 plus n minus 1 times the common difference, which is 2. And we expand the bracket. 2 times n is 2n, and 2 times negative 1 is minus 2 or negative 2, which gives us this. And we collect like terms. 3 minus 2, you can just calculate in your head, or you can bring them together and then calculate on paper. So 3 minus 2 is 1, and 2n is not like 1 because it has a variable with it, so they are not like terms, and so we leave it as this 1 plus 2n. So combine these two together. The n term rule for the whole fractional sequence is n for the numerator over 1 plus 2n for the denominator. So you see our n term for a fractional sequence is a fraction. Here's the second example. We have another fractional arithmetic sequence made up of 5 9s, 8 8s, 11 7s, and 14 6s. Again, we separate the numerators 5 8 11 14, etc., and denominators 9 8 7 6, etc. For the numerators, I am using this method. Take note, you can choose one of them which is more suitable for you or which you feel comfortable with, and you use it. I'm giving you options here. So for this method, an plus b, the n term is an plus b. A is the common difference. A is the common difference. B is to be found by substituting a value of the term, one term, you pick one term and its position number. So you are substituting three things into the general formula to find the n term for this, the numerators. Alright, so let's substitute. The first term is 5 and its position n is 1. It occupies the number 1 position in the sequence. Now our common difference is 3. That's how we go from 5 to 8 and 8 to 11 and so forth. We plug these 3 in and we solve for b. So that's 5 is equals to 3 times 1 is 3 plus b. So we minus 3 both sides, giving 2 is equals to b. So our n term rule for the numerators is xn equals 3n plus b plus 2. Take note, for this method, after we find b using xn, a, and b, we plug a and b back in, we leave n alone because n is the position for any term that we are looking for, and this is the general rule for the numerators for the sequence, so we don't know which term we are looking for, so for now we leave n as it is. Now let's do the same for the denominator. The denominators are 9 8 7 and 6, and we are using this tn method where a is the first term in the sequence. A is this term. A is the first term in the sequence, and D here is the common difference. So this method, we are just going to substitute these two things and then we simplify down to our rule. So the n term is a, the first term, which is 9 plus n minus 1 times the common difference, which is negative 1. This negative 1 is from going from 9 to 8. 9 minus 1 gives 8, 8 minus 1 gives 7, etc. So we expand the bracket. Tn is equals to 9 plus negative 1 times n is negative n, and negative 1 times negative 1 gives positive 1. So 9 plus negative n simplifies to 9 minus n, and then plus 1. We collect like terms. 9 plus 1 is 10, and 10 minus n is the nth term for the denominators. And so we combine these two. The n term for the numerators is 3n plus 2, and the n term rule for the denominators is 10 minus n. That's it for now. Do like and subscribe after you watch for more videos on maths contents. See you in the next one.